G'day, and we're going to be taking a look at some antidifferentiation of polynomials. Before we can get into that, let's take a trip down memory lane and have a look at some differentiation. So if we're going to differentiate this particular polynomial, if you remember, the power comes out the front, so we'd be writing dy dx equals, so the 3 comes out the front, and then we go x, and then we take away 1 from that power, so 3x squared. Look at the next term, the 2 is going to come out, so we have 2 times 3 is 6x, and then we take away 1 from the power, so that gives us 2, take away 1 is power of 1, which we don't really need to worry about. This next term, it's got an x to the power of 1, so we're going to go 1 times 2, so plus 2, and then x to the power of, so 1 take away 1 will be to the power of 0. And then we've got to take away 1 on the end here, which is really x, 1 lot of x to the power of 0. So that 0 would come out the front, 0 times by that would just leave us with a 0 on the end there. So that would leave us with 3x squared plus 6x plus 2. Now, antidifferentiation, which is the topic of this particular presentation, is the reverse process. So we'd be looking at how we get from this back up to the original. So let me just reduce this a little bit. Squeeze it over there. If we were to start with our dy dx, and we want to head towards y, our dy dx that we have here was 3x squared plus 6x plus 2. Now, looking at our original question, we can, up the top here, we can cheat a little bit here. We were looking for a power of 3, so what we end up doing is we have to add 1 to that power, and then if you remember when we did the differentiation, whatever the power was in the first instance, we bring that out the front and multiply the term by that. So if we're doing the reverse, what we'd have to do is divide by what the power becomes. So in this case here, we have 2 plus 1 would be 3, so we also have to divide by that 3. So this is what our y is going to equal. Do the same thing with the 6x. We've got x to the power of 1 already. We need to add 1 to that. And then we also have to divide by what that's going to become. So 1 plus 1 is 2. We have our 2, which is x to the power of 0. So we have to add 1 to that, and then we're going to divide that by 1. And we'll see what that particular function gives us. So we have 3 divided by 3 cancels out, so we'll have x to the power of 3 plus 6 divided by 2 gives us a 3, x squared plus 2x to the power of 1, just 2x. Now, if we compare that with our original function, at the top here, we notice that we had a take away 1 at the end, which we haven't got here, and we don't seem to have any way of getting it. So what we need to do is we throw this plus c on the end, and that's going to allow for any of the constants that may have been there beforehand. Okay, we'll move on to another slide. The general rule that we would have for antidifferentiation would be if we had our dy dx was equal to x to the power of n, then y would be equal to x to the power of n plus 1, all divided by n plus 1, plus c. So I'm going to teach you a little bit of some of the different ways that this could be written. We could also use the derivative as being f dashed x, and the function would go to just the function of x. We could also say that if we had the function of x and then the antiderivative, we'd use capital F, like so. And there's also this Leibniz terminology that we would use, which if we wanted to work out the antiderivative, we could actually write it this like a squiggly S thing. So if we were to do this and say 2x, for example, then we go dot dx, what this here is telling us is we want to take the antiderivative of 2x with respect to x. And this would be equal to, in this case here, if you remember, we've got 2x, and this is x to the power of 1, so I go 1 plus 1, divide that by 1 plus 1, there should be brackets down the bottom there, plus c, which would equal 2x squared over 2 plus c, which is equal to 2's will cancel down, which will be x squared plus c. Now we'll go through a few more examples for you. We'll do these ones in Leibniz terminology, their format. So if we wanted to do the antiderivative of x squared with respect to x, then that will be equal to, we go x squared, we add 1 to the power and divide by the 2 plus 1. Now we have to put our plus c on the end, which will be equal to x to the power of 3 over 3 plus c, or that could be written as 1/3 of x cubed plus c. That's that one there. See if I can reduce this a bit. Yep. I'll pick a different colour and do another one for you. So if we take the antiderivative of x to the power of 7 with respect to x, that'll be equal to, we go x 7 plus 1 and divide it by 7 plus 1. And we have to go plus c. So that'll equal x to the power of 8 divided by 8 plus c. Or that's equal to 1/8 of x to the power of 8 plus c. So it doesn't matter, either one of these last two is correct. Make that one there a bit smaller. Nope, squeeze up. Not going to do it for me. No one. We'll move on. And the other type of thing that we can do is we might be looking for the antiderivative of 3y with respect to y, dy. So it works exactly the same way, but instead of x's, we're dealing with y's. So this one would be equal to, we go 3y, and that already was a power of 1, so I'll add 1 to that power, and then we'll divide that by 1 plus 1. And then we go plus c, so that would be equal to 3y squared over 2 plus c. And if we do one more example, I'll just pick a different colour out here, nice green. If we were to have something like this, but I'll do, if we want to do the antiderivative of, say, 3x to the power of 5 with respect to x dx, that's actually equal to, what we can do, this 3 is a constant, so we can bring it out the front. And it's equal to 3 times by the derivative of x to the power of, antiderivative of x to the power of 5 with respect to x, which is equal to 3 times x to the power of 5 plus 1 divided by 5 plus 1, and then that goes plus c. So that would actually be equal to 3x to the 6 over 6 plus c. 3 and the 6 will cancel down, which leaves us with a half x to the power of 6 plus c. So there's a few different examples there. like so. We'll move on to a couple more. Now, if we have a question which has got multiple terms in it, so we're looking for the antiderivative of 3x squared plus 4x cubed plus 3 with respect to x, then we just deal with each term individually. So that's 3x squared so dealing with each term individually, so we go 3x to the power of 2, and then we go plus 1 on that and divide it by the 2 plus 1. Then we go plus 4x cubed. Again, we need to add 1 to the power, and we'll divide by 3 plus 1 in here. And then we have our plus 3. And that's really 3x to the power of 0, so we're going to go 0. And we'll divide by 1. And then we can't forget our plus c on the end. So that will be equal to 3x cubed over 3 plus 4x 4 over 4 plus 3x 1 over 1 plus c. Cancel a few things down. That will leave us with x cubed plus 4 plus 3x plus c. Okay, how do we find this c value? We'll move on to that now. What we need to do is be given a point that it's passing through. So we might be told, for example, that we have a derivative which is equal to x cubed plus 4x squared, and we might be told that when x is equal to 0, the function of x is equal to 0. So what we can do then is, firstly we need to do the antiderivative to find the function of x. So the antiderivative of x cubed plus 4x squared will be equal to x, 3 plus 1 is 4, divided by 4, plus 4x, 2 plus 1 is 3, and we divide by the 3, plus c. So that's what our function becomes. But we're told that when x is equal to 0, that the function is equal to 0. So that will tell us that if we have 0, the function of 0, will equal 0 to the power of 4 over 4 plus 4 to the 0 cubed over 3 plus c will be equal to 0. Yeah, that's 0, that's all 0, so that'll tell us that c is equal to 0 in this instance. So that way we get our function of x equals the 4 over 4 plus 4x cubed over 3, and that will be our answer. Okay, we'll do another example. If we have a function of x is equal to x squared plus 3, and we're told that the antiderivative of that passes through then what we need to do is we take the antiderivative like we normally would. So the function big F of x will be equal to the antiderivative of x squared plus 3 dot dx, which will equal, so we go 2 plus 1 is 3, so x to the power of 3 divided by 3 plus 3x, so that'll be x to the power of 1 plus c. But we now need to substitute this point in here. So 2 will be equal to 1 cubed over 3 plus 3 by 1 plus c. So that's equal to a third plus 3 plus c, which tells us that c will be equal to negative 1 1/3. So therefore, our function f of x will be equal to x cubed over 3 plus 3x, take away 1 1/3 or take away 4/3, because this thing here is equal to negative 4/3. And that will be that one there. Hope you find that useful.